Good evening. My name is Mr. Zaldur. I'm the Head of Physics here at Caulfield School. Welcome to the presentation. I really just wanted to give you a feel for the physics course and outline the content and the assessment and some of the opportunities that are available to students with a physics A-level. The first year deals with the topics particles and radiation, waves, mechanics and materials and electricity. Over the last couple of years, we've had a couple of really successful trips to CERN in Switzerland. I'm hoping we'll be able to go towards the end of next year, fingers crossed if we can for obvious reasons. But that is a great supplement to the students' understanding and really builds on the understanding that they have, that they gain doing the particles and radiation course. Waves, mechanics and materials and electricity again build on that understanding, but start to look in more detail at the sort of fundamental nature of those aspects of physics. In the second year, the further mechanics and thermal physics deals with things like circular motion, simple harmonic motion, forced vibrations and resonance, energy transfer and ideal gases and so on, kinetic theory of matter. Fields and their consequences is also quite a large sort of subject area, dealing with sort of magnetic, electrical and gravitational fields. Students tend to find that the second year a bit more challenging than the first, just because of sometimes because of the mathematical requirements, but also the conceptual requirements for the understanding of those topics. Capacitors as well, which links on to electricity and their understanding of electricity, and nuclear physics. In year two, the course is structured so that students have options to study the astrophysics, medical physics, engineering physics, turning points of electronics. Traditionally, we have worked towards the turning points. We've chosen the turning points topic. That's not to say students can't study any of the other ones, but that's the one we'd recommend. You know, myself and Mrs. Dexter have the most experience with that, and we find we have the best results with that option. And that boils down to three main topic areas in turning points: the discovery of the electron, wave-particle duality, and special relativity. So it covers discovery of electrons, very interesting, deals with the discovery of the fundamental particle, its implications, accelerated and accelerators and particle accelerators, which is, it's really good stuff. Wave-particle duality and special relativity, and Einstein's great discovery of that, and students always find that really interesting. There's also quite a lot of work done with the practical skills. The students have to pass a set number of practicals, and they have to show that they can work carefully, they can work safely, that they're able to handle data, and they're able to work together. So that's an important part of the course, and the students need an accreditation in that in order to pass the whole course. In terms of assessment, it's 100% written examination. It's 3 papers. Each paper is 2 hours long, roughly a third each in terms of the whole A-level. Papers 1 and paper 2 include about 26 marks of multiple choice questions and about 60 marks of longer written questions. The paper 3 assesses their practical skills, and it also is the one where the option, turning points, probably is the one where they assess the option paper. In terms of what's required to get onto the course, students will need either a lowest of 6.5 in combined science through the higher tier route, or at least a 5 in physics, with a grade 6 in maths at GCSE. Many students that study physics will also be doing maths as well, and we tend to find that those students will have an advantage. It's that having that mathematical fluency means that they're able to sort of handle the variables and identify some of the skills and tricks and become fluent in themselves that allow them to access the high marks in the A-level. That's not to say that students who don't do maths don't do well, but we would recommend that the A-level is studied in conjunction with maths. And in terms of future pathways, there are many careers that students can go into from A-level in physics, and therefore maybe sort of an A-level or a degree level physics as well. Just a few things there that that came to mind in terms of careers. Myself, for secondary school, I noticed the secondary school teacher was there. Myself, I got a physics degree, and I went into semiconductor technical sales and marketing for about 10 years, and then I saw the light and came into teaching. But no, it's been good. It's been a really sort of worthy career to have, and I enjoy teaching the students physics and science. Well, I hope that's been given you a bit of a feel for the course. And if you have any questions or want anything clarification, please email me and I'll get back to you. But thank you very much for your attention, and hope to hear from you soon. Thank you very much.